Hi girls, so we are starting a new unit and we're going to be taking a look at triangle trigonometry. So we're going back to our geometry, and I thought we would start off with a place that seems probably familiar, is the Pythagorean Theorem. So I've included a little link here for you to check out. It is a TED Talk on ways to prove the Pythagorean Theorem, and just gives you a little background. So in your spare time, if you're feeling bored and you want a little bit more information, it's a quick little video just to kind of reinforce what the Pythagorean Theorem is and why it does work. But for our class today, I'm going to walk you through the application of the Pythagorean Theorem, and we're going to practice a couple of problems. So you can go ahead and follow along with your guided notes. So let's start off with the definition of the Pythagorean Theorem. So what this theorem says is that in a right triangle, so you can see this blue triangle here on the right, the square of the length of the hypotenuse which is talking about this long side here, this long side C, is equal to the sum of the squares of the lengths of the legs. So they're talking about the legs of the triangle. So side A and side B are called the legs. So we can identify where the hypotenuse and the legs are based on the triangle itself. So where you see that right angle, if you draw an arrow across from that right angle, we know that this is the hypotenuse. And then we know that these other sides here are called our legs. So again, the square of each of the legs added together gives us the square of the hypotenuse. You may find it helpful to memorize some of these basic Pythagorean triples that I included in your notes. It's just going to be helpful when we are looking at this particular example, because in the directions they do tell us to see if the side lengths of the triangle actually forms a Pythagorean triple. So let's take a look at example A. So we've got this right triangle here, and just go ahead and draw in the right triangle symbol here for letter A. We're going to find the value of x. So if I think about this, I know that if this is my right angle, across here is going to be my hypotenuse, or what I call C, right? And then my legs are going to be A and B. So if I want to set this up, I could say that A squared plus B squared equals C squared. So therefore it would mean 5 squared plus 12 squared has to equal C squared. So I can go ahead and evaluate this. 5 squared gives me 25, 12 squared gives me 144, and that's equal to C squared. So then I'm going to add these two numbers together, and I get 169 is equal to C squared. So I'm just looking for C, not C squared. So to do that, I'm going to need to find the square root of 169 in order to find out what C is equal to. And if I just type that into my calculator, I'll get an answer of C equals 13. So if I know that my sides are 5, 12, and my hypotenuse is 13, I look up here and I see, oh, this is in fact a Pythagorean triple. So therefore, because the side lengths are 5, 12, and 13, yes, it's a Pythagorean triple. So I'm going to just put yes. All right, if you want to pause the video and go ahead and try B on your own, but before you do that, go ahead and mark this angle here as being your right angle. Okay, so we're going to set this up the same way we did the last problem. We're going to first identify the hypotenuse, so that's the side that is across from my right angle. So this is going to be my hypotenuse, or C, and then my legs are going to be A and B. So I'm going to use that A squared plus B squared equals C squared. So that means x squared plus 7 squared is equal to 14 squared. All right, so I'm going to go ahead and evaluate my squares. So I get x squared plus 49 is equal to 196. Then I'm going to subtract 49 from both sides. And I get x squared is equal to 147. And just like in the last problem, I need to find the square root of both sides. So I'm going to plug that number into my calculator, and I get x is approximately 12.12. So the side lengths of my triangle are 12.12, 7, and 14. So I'm going to look up here at my chart, and I do not see those numbers. In fact, all of these are whole numbers. So this would not be a Pythagorean triple. All right, let's take a look at our last example, which is going to be an application, or what we like to call a word problem, involving the Pythagorean theorem. So I've got this picture here. These are two skyscrapers, and there is a walkway, this walkway here, that is connected to both of the sides. The skywalk is connected to both of the skyscrapers, and then we have these support beams that come down, and they form these two right triangles. So we're going to use the Pythagorean theorem to approximate the length of each support beam. In other words, we're trying to find the length of x here. So if I just focus on this triangle here, I'll just make it a little bit darker so we could see it stand out. Right, and I know that this is my right angle. All right, so if I look for my hypotenuse, that's going to give me x, and then the lengths of the sides are listed here. So let's go ahead and plug that into our Pythagorean theorem. So that means that this side is C, this side is A, and we'll call this side B. So we're going to say a squared, so that's 47.57 squared, plus side B is 23.26 squared, has to be equal to c squared, which is x in this case. All right, so using your calculator, go ahead and find the square of 47.57, and then find the square of 23.26, and when you add them together, you should be doing this all on your calculator, you would get an answer of 2,803.932. And that is equal to x squared. And then just like in our last example, we're going to find the square root of that number so that we can find out what x is equal to. So x is going to be approximately equal to, when you find that square root, you should get 52.95 meters as our final answer. And that makes sense if you think about this side has to be longer than this length here, but not too much longer. So we can see that it's 52.95. And that does it for a review of Pythagorean theorem. So you're going to complete a couple of problems out of your textbook for an assignment today, and then we'll pick up with finishing up the Pythagorean theorem at our next class. Talk soon. Bye.